Okay. Okay. Good evening, everybody. Welcome to our dot show. This time we'll be doing a dot show about the dark region near the Wadden. And I'll be doing this show together with Nidhi, which will show up in the camera in a few seconds.
Hi, I'm Nidhi. And so, yes, today's show will be about the dark skies in the Wadden area.
It's a bit hard to find a good camera angle.
But we'll make it work. So normally we give the shows in the Planetarium, but given the corona situation, that is no longer possible. So till it permits again, you cannot see me anymore, but we'll fix that. But I hope you can hear me and still enjoy the show. So till we are able to have physical shows in the planetarium again, we'll be having these shows online using OpenSpace. This is a free software, and in one of our previous videos we have explained how to download and use it. So today we'll be going into that without explaining how to use it in much detail. However, if you still have any questions, you can always put them in the chat box and we'll try to address them as much as we can.
So yeah, we already started OpenSpace, and we're still trying to make the camera work. We had it for a second. So we already started it, and it's not showing up somehow. That is very unfortunate. Let us start it again. Can you click it? Oh, I think it will show up. Yeah. Okay.
There we go.
So there we go. So we already started up OpenSpace, and as you can see, this is the same screen we got the other times, and it shows us the Earth. And what we're gonna do is we're gonna turn around and show you the difference between the daytime and the nighttime. So as you can see right now, we're mostly looking at the day, and this means that the sun is on the left of our screen, and it's shining on that part of the planet, and on the other side is the dark part, and that's where it's night. So if we go to that part a bit faster, obviously normally it would just be dark on the other side of the Earth, and we would pretty much have no light, and this is also how biology evolved to work. But we humans did something special with it, and you're bound to notice this as soon as we're scrolling through. As you can see, there are small dots of light, and this is the light pollution we are going to talk about. It's a pretty interesting thing, not just for astronomy, but also for biology, and that is because it affects a lot of different creatures, human, but also different kinds of animals. It affects them in different ways. So let's first look at one of the very specifically lit regions, which is the Nile here in Egypt. And this is because humans need fresh water to survive, and so people settled near Egypt, all near the Nile, because this was a place where there was a lot of fresh water, there was a lot of fertile ground. So yeah, that means that there were a lot of people, and fast forward a few thousand years, and you'll see that there will also be a lot of light that we created.
If I fast forward a few hours now, we can see the light pollution in a lot of other major cities around Europe too. Where we see Italy, we've got Spain, we've got France, and right there is the Netherlands, where we're broadcasting from.
Yeah, so below the Netherlands you can see one of the most light polluted lands or countries in Europe, and that is Belgium. You can see that even all their highways are lit up. You can see that everything, their major cities are lit up. So that creates a lot of light pollution. But it is not just the countries here that are lighting up. It's also something else.
So we've got these oil rigs, oil platforms in the water that are lit, and these affect the birds that are migrating as they are distracted by the light and can disrupt their migration pattern, causing them to even starve on occasion. Another way that the light pollution affects the birds is simply because they are not accustomed to light in the dark. Many birds are also active in the dark, which does disrupt their lifestyle and their breeding habits.
Yeah, so this is one of the types of species that is affected, and we humans are affected in a kind of different way because our body produces melatonin when we when there's no light around us. So melatonin makes us drowsy, makes us sleepy, and if there is no light around, that actually gets produced. But light suppresses this. So as long as there's light around us, there's actually no, yeah, it doesn't make us tired, and we keep active, and that is very bad for our natural rhythm, and that's how it affects humans mostly.
Another another species that is affected by this light pollution are the turtles, for example, in Florida. They hatch along the beach and they are drawn to the water by the reflection of the moon in the water. However, because the cities are so polluted with light pollution, they instead travel through the cities, which is very dangerous for their health, and they might be run over or so.
Yeah, and this is very bad because there. Yeah, so this is one of the problems for nature, but there's also a problem for us astronomers. We in astronomy, we really like it when a place is dark, a place is high, and a place is dry. And we do this because we make pictures of the universe with sort of cameras, and these cameras are yeah, the idea of them is that you have a lot of dark and that things that you want to see in the photos, they actually light up. So if there's a lot of light around you, like light pollution in major cities, you can't see the objects that you want to observe very well, and you just see a lot of light in your camera. Just like when trying to take a photo of people behind a big spotlight, which is not an ideal place to take a photo. And one of the places where we do that is in the Atacama Desert. This is a place in Chile that we're now navigating to, where ALMA is. And this is one of the largest telescope clusters that we have. And it uses 66 different telescopes to combine one image. And the good thing about the Atacama Desert is that it's very dry, as it is a desert. It is very high because it's also a big volcanic area because of the land masses. We have talked about this in a few other videos.
And if this would load, then we'd see in this region we have the ALMA telescopes. But as the software uses live data from NASA, it does take a bit of time. We're right in the area.
So you can slowly see the patterns forming, and those are trackways that they use to move the telescopes. It's slowly clearing up. And while it loads, we're going to show you a bit of the 3D effects that open space gives. And you can see that very pretty like this.
So we have these high altitudes that allow for the dry atmospheres, the dry conditions that make this a very useful spot for astronomers. And let's see if it's loaded yet, and we can show you the actual area of the telescope, which is not in fact one telescope, but an interferometer made of 66 telescopes put together. We do see it a bit. Let's see, there we are, right in that area.
So that's where they're stacked together, and you can see the trails where they move them. Those are over there. Yeah, over there. But this is not the only place where a big telescope is, or where a lot of telescopes are that we astronomers like to use. And for the next one, we'll go to a very famous holiday spot, maybe a bit expensive for some, and maybe some go there on their honeymoon. But it's a very famous spot for people to go on a holiday, and that's Hawaii. And Hawaii is very little. It is located on a hotspot, which is a place in the crust of the Earth where a lot of lava is coming out, and when the tectonic plate, the oceanic plate, is moving past it, it leaves a trail of islands behind it, and those islands are called Hawaii. And this is where we are searching for the biggest of them, which is
Mauna Kea.
the big island with the mountain Mauna Kea, which is also a very good place for us to observe.
There we see it with its own little bit of light pollution in the dark, which helps us navigate to it, really.
Yeah, so even though light pollution is in general a bad thing for astronomers and humans and some animal species, it is very useful to navigate to Hawaii in the dark. So when we make up light,
and we see this one being the largest island where our telescopes are located. And these telescopes are not just from one country or one observatory. You have telescopes that are from the US, from China. You've got a collaboration between France, Canada, and Hawaii. And as soon as these loads, you'll be able to see much clearly just the amount of work happening in this area.
the map is still getting loaded, but so this is it's a dead volcano, so because the hotspot moved away and islands are created elsewhere, there's no live lava coming towards this island. So it is safe to stay there, it is safe to be over there, even though the air may be a bit it means there's very little oxygen in it, so it's kind of hard to breathe, but it's safe because it's not a live volcano.
Unfortunately, this does tend to take a bit of time.
We're seeing a few maps being loaded, but yeah, so this hotspot is populated by a lot of telescopes. There's one from the USA, one from NASA, which is, there it is, and there's one from France and Canada, which are collaborating. And if it starts loading,
there we see it. So this is the hub of the activity. With the various telescopes, as you mentioned, we have one that is Canada, France, Hawaii, we've got NASA, we've got Chinese telescopes here, the 7mm array. There we go.
it's still a bit vague, but you could go to maybe Google Maps, or you could go there on a holiday. Look, now they're looking pretty. You could go there on a holiday. It is hard to visit them because they are usually only meant for people that are there. And you might think that now astronomers have a great time and that they can go to these places all the time, but the sad truth is that it only takes a small number of astronomers to operate these telescopes, and usually when you have to work with their data, it just gets sent to your office and then you have to work with it from there. So when we move back to the Wadden area, there's something that the Netherlands doesn't have. It doesn't have very high places, it also doesn't have very dry places, but what it does have is a very dark place, or for Europe, reasonably dark. So this is the Dark Sky Park in the Netherlands, in the northern region of the Netherlands, and we use it for a lot of things, but the most interesting is for people to watch up at the sky and be amazed. And how we do that is because a lot less light is coming from different artificial light sources, and that makes sure that, just like a camera that has pixels that creates an image, our eyes, they have rods and cones, and the cones, they catch the colors, the wavelengths of the light, and that creates a color in our brain. And the rods, they measure the intensity, and when there's very low intensity, they bundle together in the dark to form a better image. So they bundle together, and that's what your eyes are doing when they are adjusting to the dark. And that's why we try to make as dark as possible place. It is for nature to be at rest, for birds and others. And the other is for our human eyes, so we can watch the sky and we can enjoy it. So as we approach the Netherlands, we can see that the Randstad, which is the major big cities like Rotterdam and Amsterdam, it is very light and very bright, and that's most definitely not the Wadden region. But in the north you can see that there's a lot less light pollution. And what you can see is that in the north, where the islands are, when we make a day, yeah, between the few islands we have and the right side of the mainland, that is where the Wadden area is. And we are hosting a lot of different projects to enjoy and encourage the dark skies.
So, let's zoom in. Of course, other than just astronomers, even the general public that enjoys looking for astronomical events would enjoy a dark sky. For example, just this past month we had 2 astronomical events that were very interesting. We had the comet Neowise that passes us by only in once every 6,000 years or so, and we also had a yearly meteor shower. So if you have dark skies, if the cities weren't as polluted with light, you'd be able to see these events from mostly anywhere. Now we approach the Wadden area, where we're building a telescope that we hope will be used by researchers and students from all over the Netherlands and this region, and it'll also be it's intended for it to be open to the public, so the public may also enjoy the effects of having a dark sky, of having that beautiful view.
So as soon as the telescope's complete, the observatory, then there will be public events that will be held there to go to watching the sky, to go stargazing and other stuff just like that. So if you follow us on Facebook or other places, then you can get to join them once it's finished. But it's not finished yet. In the meantime, we have a few other places near the Wadden region that are used for watching the night sky, which are specifically made. And one of them is near Schiermonnikoog, one on the right, yeah, that one. And the dunes over there are being kept as dark as possible to have people go over there, and so people can watch the night sky without light pollution being obstructed. Another one is on Terschelling. This is the sky barn and the night barn, and this is a exposition of different kinds of pictures and other works that indicate and love the love for the dark and a dark area.
Another area are the star barns in North Holland, that is essentially a watchtower where visitors can see up to large distances and appreciate the effect of just having darkness versus having a lot of light obstructing your view. So we've spoken a lot about the effect of light pollution on humans and animals, but of course we also saw that it affects, as astronomers, our view and our understanding of the universe. What are some of the things, what are the consequences, what are the things we cannot see as clearly if we have a lot of light pollution? Well, if we go further away from the Earth, we can have a look at a few of those. The first thing we see, of course, is the orbit of the Moon, which is not a source of light pollution, but it is a source of light in the night sky, which does still inhibit a certain amount to what the stars we can see, and so on.
So sources that are naturally giving off light, so that are not ours, like the sun and the moon. Well, the moon doesn't give off light, but it only reflects it. What happens is that we call them not artificial light or light pollution, but these are just natural light sources. Because also nature adapted to it, so so different kinds of animals use the moon to hunt, or they have a specific cycle that goes that depends on the time of day, and they use the moon to as a sort of way to tell the time.
So now further out, of course, you see the first 4 planets of our solar system. You've got the Earth right there, you've got Mercury, Venus, Mars, the one that is closest to us and that you can see in the night sky as being the red planet. Venus, the one that is closer to the sun, so you can see it in the hours following sunset or in the hours leading up to sunrise. Further out still, you have the giant planets, Jupiter, Saturn. Then you've got
Uranus and Neptune. And if we get the angle right,
perhaps even Pluto. There we are, the little green dot right there.
Yeah, and something that you may not see now in big cities, but you could see if the light was less polluted, would be constellations. So we would like to show you some of them. Yes, and these constellations are not used by astronomers in any way except tell what is where. So we use them to mark a specific region in the sky where we can discuss what we're looking at. They also get the name if there's a meteor shower and it's coming sort of from the direction of a certain constellation, then they usually get the name. Like the Orionids from the constellation of Orion.
And you had the Perseids meteor shower because they are in the direction of the Perseids in the sky. So, but these are still, of course, beautiful, and we appreciate the mythology and the imagination that went behind them. But besides just the constellation, there are other objects that you can see in the night sky, and let's see if we can find them. We've got the Magellanic Clouds, if we can find. Oh, we find a rather beautiful angle at the Milky Way itself, right there.
So this is something you are able to enjoy when you're in the dark sky park, because in a light polluted city it is not very easy, or it is impossible to see the Milky Way. And even if you think you've seen it, it looks so much richer when you're at a dark place, and people forget how that looks because there's very little time where you actually spend in the dark.
Turn off the constellations, we can have a look at the others beautifully. We have the Magellanic Clouds there and there. But stars, as you can see, of different colors and sizes. And all of this we'd be able to appreciate so much better if we had darker skies and less light pollution. That brings us to the end of today's show. If you have any questions, please put them down in the comment section, and we'll answer them. We'll do our best to answer them. We hope you've enjoyed the show. We hope we've been able to explain how light pollution affects the earth, the people, the animals, and all of our lifestyles. And with the project, The Darkness of the Wadden region, we hope that we can create an awareness for these problems, and we hope that we can arrive at some sort of solution or just try to improve the problem. We will keep you posted about our next shows via Facebook and Instagram, so you can follow us there. If you've enjoyed this show, please leave a like and subscribe for the next shows. We hope you have a great evening. A link to one of our Zoom session will be posted in the comments in a few seconds, and you can join us there if you have any other questions regarding either this program or the darkness, or the project we have in the Wadden region, or just to say hi. So we'll hope to see you there, and if not, we hope to see you at our next video. Yeah.